Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench, I have another Yamaha natural sound stereo amplifier. This one's the CA-610 Mark II. Now, they made a couple of 610s. They had the 610 and then the 610 Mark II. This is the second generation, I guess. So it's got some differences in circuitry. I don't know what the difference is. I haven't pulled out the things and looked at them, the schematics, and looked at them to tell the difference, but this one's in for a full refurb. It's nice, clean. It's very nice condition. Cabinet. It looks like it has a vinyl wrap, but it looks like it's very good condition. The corners are nice and sharp. There's no, oh, hang on, I spoke too soon. There's a bang up back here in the corner, but the rest of it looks good. The front, the top is good. Aluminum is nice. No big scratches. It's clean. I don't know if this works or what. This is brought to me by a client. He says go through it. I haven't tested it yet, but I don't think he gave me any indication on what's wrong with it, if there is anything wrong with it. So let's... Oh, that's really stiff. That's overly stiff. I'll have to fix that. This one's a little stiff too. This one's okay. Ooh. Something wrong with the balance. There's the center and it's marked off at 6. I don't know if that is just a matter of the knob is out of position. Something feels weird on that end. Okay, I felt a crunchy feel when I was playing with it earlier, so yeah, we'll get to it. We might have to do some potentiometer surgery. We don't know. So I think what I'd like to do, well, let's have a look inside. I don't know what kind of power this thing puts out, but it's got a nice big vent in the top here. It's probably about a foot long. Good 4 inches wide anyway. With lots of air through. Let's remove the cover. Top looks really nice on the inside. No dark staining, not dirty at all. This client brings me cleaned. He likes cleaning his inside of his equipment before he brings it to me. Maybe he's embarrassed by the dirt, I don't know. But I don't mind. I don't mind it when it comes dirty. Cleaning's part of the fun for me. Oh, somebody did some butchery here on the lamps. I'll show you in a bit. But we got a nice power transformer in the back corner. Got our switching at the back here, which is good. Nice and close to the inputs. Got the phono stage. Inputs are input switching and record selector. That's back here, and it's got the long shafts, so that reduces hum and noise pickup. Instead of putting the switch at the front, you put it at the back, shorten the leads, and it reduces hum pickup and noise pickup. We got a big aluminum plate here in the center, and we have 4 transistors, 2 on each side. What else we got here? We got a big board. I'm assuming it's one big large board, and we got everything on the one board. We got our power supply and circuit protector here, power supply, and then we have our power amplifier stuff going on here, and here and here is our power amplifiers, and then tucked underneath you're going to see all our tone. We have a tone board here. This is our bass and treble control with our tone defeat switches and our hinges, so that's all up here. Let me turn this around. Here's a look from the other side view. So we have 2SA-745s, 2SC-1403s, complementary pair from Sanken. So they're all original transistors. That's good. Very nice. And then you can see underneath a bit here with the shadows. I don't know if you can see the tone amplifier part. Here's a metering board for the meters. Volume control board for a volume pot. And then we have, now I remember what he told me. He told me there was some butchery going on with the lamps, and the previous owner did. So look at, somebody did here. I don't know what this is all about. I'll clean that up a bit. I don't know why we would do that. It's so violent. I have to flatten that out now and kind of straighten it. It's pretty sharp and jagged. Just to get 2 lamps in. I don't know. There's easier ways of going about things. You don't have to get so angry. So it's loaded up with Mashishita caps, it looks like. But these are early Mashishita caps. I don't think these are the ones that leak themselves. But we're going to replace them anyway. There's the 5-leg transistor here. This is the 2SA-798. These are notorious for going bad. They use these in the long tail pair. On the audio amplifiers, there's one here and there's another one here. Some people say replace them on site. I don't know. If they're working good, I'll leave them alone. The problem is these have the silver legs and that turn black, and then the silver corrosion migrates up into the body of the transistor and causes problems. These ones aren't corroded. These legs aren't corroded at all. So they might be okay. But they're easy to replace. You can just take them out and replace them with two SA-992s. And it's just as good as the original. So this will get all new caps. I'm going to give it a quick test here to see if there's anything wrong with it. I don't think there is. I think everything works. Here's caps. We'll service the relay, and we'll fix up the butchery here on the lamps, get that sorted. We'll probably put LEDs in. I don't know what they're using now, but we can clean that up. This balance pot has me concerned though, because it was feeling crunchy before I turned the camera on, and now it's not crunchy anymore. Still kind of doing weird feeling. It's still kind of making weird feels and noises. Okay, let's have a look at the bottom. Okay, bottom plate off. Shows 2 boards. I thought it was 1, but it is 2. Looks pretty good. I just gave it a quick look. I don't see any cracks, solders anywhere. But I haven't looked too carefully yet. And then a nice clean, and you'll be able to see better. So this will be a nice, easy job to go through. Be a change from all these monster receivers I've been doing lately. This will be a little breeze. So I'll get started on replacing the caps. Going through, actually I want to power it up first and test it. I don't know if I'll do that on camera. I'll probably do it off camera. It saves you guys watching a boring test. Yeah, it's nice. Probably expect the same as every other receiver I've opened up, is dirty switches, dirty relay, you know, the typical stuff, scratchy controls, all that stuff. So I'll spare you the agony of watching all that, and I'll just come in and let you know. I'll start on the recaps, and I'll come in and let you know if anything's changed or if I found anything interesting to talk about. But yeah, I'll just get started on this. Yeah, it's messed up. You know what's going on here? The balance pot has been turned past its stop and bent inside. So when I go past where it's supposed to stop, it makes a disconnect. And yeah, it disconnects that signal. The wiper disconnects from the track. We're gonna have to fix that. This side seems okay though. But oh, Yeah, this is messed up, seriously messed up. It does it on both sides. And I can turn the knob farther than the stop on both ways, so something's broken inside that potentiometer. So we're going to have to do something about that. And these lamps are really bright. Like, holy cow, you can read by them. Get your book out, boys. So I think I know why they butchered holes in the back here to get the lamps in, because this, we can't get this off. This is either glued. Looks like somebody used an adhesive here. It wouldn't be threaded on. It would have to be pressed on. So I'm going to pull on it. And it's just not budging. I'll have to figure out what to do. Maybe I have to get some heat on here. Well, at least they didn't try prying and making big gouges, so I have to figure out how to get this knob off. Yeah, call me an idiot. I didn't realize there's set screws back here. I keep forgetting on these Yamahas they use set screws. Let's see if I can get this. 2mm. Oh, look at that. Comes right out. Even one set screw is already missing. Have to see if I can find another one. Wow. I got caught by that. And you can see where they removed it with brute force. You see the gouges? They tried spinning it off and pulling at the same time. Those gouges are made by the set screw. So that's the reason why the pot's broken inside, and it goes beyond, it stops. Somebody was really cranking on this, and they really messed up the internals of that potentiometer. Alright, here's a look behind the faceplate. So maybe they did get in here, I don't know. Looks like they hot glued these LED lamps. These are fuse style lamps that they attached wires to. And they just hot glued them on top of the meters. This black foam that somebody added along the bottom to block light. There's foam here to block light. But it doesn't look like there's any provision for lamps inside the meter housings. So let's get this. This is all hot snotted together. There. Alright. Just, wow, I have to clean this up. Removed all the big caps and the relay, and then it gives me room to work. I got to remove all this corrosive glue, and there's a couple jumpers here that have turned green from corrosion. So I'm going to pick this out and get this cleaned up. I don't think they're damaged. They're still there. Just crustiness. So we got to clean up all this glue. There's some down here too. You see all this. I'll remove all this. So I got the front plate off. I'm going to take it out to the garage where I have an anvil, and I can start reshape. Oh, I'm going to try and flatten this back out again. There's no need for that. Cut yourself up it's pretty sharp. So I'll fix that up. Okay, let's see what we can do for this. I don't have high hopes because this thing's broken inside, and opening these up, you're pretty much going to have to destroy them. Now we have, it's a coaxial shaft. We have an outside, this brass part here is the outside balance control. You see it turning, and then the inside aluminum shaft is your volume. Now the volume goes through the first two potentiometers and comes out and activates the second two, and if you can see that inside that window, you can see things moving around there. And then this shaft here is connected to these two wipers. So that's where our problem is. This here and this here is the stops for both shafts. So this is what limits the travel of the rotation. I don't know if you can see this. I'm going to rotate it counterclockwise, and look in this little window here. You'll see a white piece of plastic appear. That's the stop hitting right there. Okay, now I'm able to turn the shaft farther, than that. See how it turned? Now if I go the other way and bring it back, here's the center position. Keep going, and there's the piece of plastic. And this shaft shouldn't be able to turn once it hits that stop, but it is. I can still turn it. So probably what happened is that white piece of plastic in there is split and it became detached from the shaft. So how do we fix this? This is the question. Let's try removing this end cap. Let's try this first. I don't think we're going to get in this way though. Typically they're constructed see, what is that connected to? It is. I wonder if I lift these. Let's see here, I need let's try this. If we can get inside and have it get it disassembled, we can glue that piece back together. That's what I'm hoping, but I don't think we're going to get inside. I have a feeling this is not going to work. Let's try this. It's actually loosening up quite a bit. So will this come apart? It will. Look at that. Okay, we need to get this all the way out. And we're stuck. Maybe we don't have to open that up. I can see the problem right now. See this brass sleeve? It's crimped onto this white piece of plastic. So if I go and rotate this plastic, I'll show you. You see this there. Now what I need to do is fold these two ears back down to catch on the plastic, and that will position the let me try this. See if I can fold this down. It's brass and it's really, oh yeah, there's a ball bearing that came from in there. What I need to do is hammer that down. So let me get set up for that. Okay, what I'm going to try here. This might not work at all. I'm just going to try clamping this. And I'm just going to try finagling this piece of brass back down. Because, yeah, I think it's going to work. Okay, let's try the other side. I hope you can see what I'm doing here. This brass ear needs to go. There. That's what I wanted. Okay. Now I can work on this. You see what I have to do? I have to spread this out and flatten these back down onto the plastic. It's kind of locked in now. It's got a little bit of play, but what I need to do is put this on an anvil of some kind and maybe hammer on this to get it to flatten. Got to be careful though, because we don't want to bugger up any of the trace or the track. Yeah, and this here, I can just close this back up because we don't need this open. Okay. Yeah, there's a little bit of slack there. I want to make sure it's tight. I think this might work. Just lay a screwdriver down here as a base, and then put this on top. Tighten this down a bit. And that gives me something to hammer onto. I have here, I got punches. I'm going to use a punch. And I need a hammer. Okay, here we go. This might be a little, this was better. This is going to be difficult. Turn it. Turn it this way. There. Let's try this side. Actually, it's not too bad. I think we're getting it. It's tight. Just want to get this flatter. I don't go too crazy because I don't want to start breaking things. Much better. And you can see that I kind of flattened it out. A little too tight, but we'll put some oil on there. Yeah, I'm pleased with this. This is going to work. Now we just put this back together. Okay, I'm going to have to see why this is. There we go. Okay, now before I put things together, I want to do some lubrication here. So let's get some lube going. What do we have? Just want to put a little bit on the inside here. And we need, where's our ball bearing? Put this a little bit here, and then we can put our ball bearing back on. The grease will hold it. I'm going to leave everything else alone. So let's put this together. Come on. These are a little tight. Okay. Now, before I crimp anything, let's check our range of motion. Balance is tighter. Quite a bit tighter because and it's not, yeah, it's good, it's holding. Okay. We just have a little problem with lubrication. Okay, I'm going to crimp this. That went actually a lot better than what I expected. Okay, crimp this. And that's crimped, everything's back together. Okay, let's have a look at this relay. It is a double pole, double throw with contacts on both top and bottom. Great big beefy fat contacts is a good sign for high current. Okay, so let's check. Normally open, normally closed, I mean. We got 9 milliohms. That's really good. The other side, 9 milliohms. Okay, let's try our normally open contacts. That's good. And again, 11. This is actually this relay is in perfect condition considering its age. That's a first. But what I'm going to do anyways, I'm just going to give him a polish and just you can see the contacts there and there. They're not pitted or burnt or anything. A little bit of oxidation. It's probably some silver alloy with something or other, who knows. So I'll polish these up. And then we'll put it back together and test it one more time. Okay, so I just cleaned and tested this. We got 9 milliohms on the contacts both sides. And I happen to think this might not even be silver button on here. This might be something like palladium. Just because it doesn't look like silver. It's kind of a dull gray metal. And doesn't oxidize. So it's probably some other alloy of silver that's probably a little more exotic. But anyways, that's good news for us because less cleaning and longer life for the contacts. So I'll put this back together. I'm just going to take this and clean this in the ultrasonic just to get out any residue, and then I'm going to put it all back together and then we'll continue on. Alright, here we are again. We got it all finished and I just want to give you a quick look at what we did. So all the caps have been replaced. Used film caps in positions where they had low value electrolytics, and I'm also using solid polymer caps in areas where they have emitter bypass resistors and you want stability and you want low ESR in those positions. I'm sure. Now the transistors were replaced with they were put back in, but the thermal compound was replaced cleaned up and replaced on both these and these two. So everything's good. These two switches were removed and totally cleaned inside and reassembled. So these are like two brand new switches. And the volume pot, we did the repair on the balance portion of it, and hopefully that's going to hold up. I'm not guaranteeing anything on that one. Here's the amplifier section, and you see the new caps in here. I haven't touched the trim pots because I don't know what condition they're in. If they turn out to be okay, I'm going to leave them alone. Yeah, so here's the power supply. The caps in the power supply are quite a bit smaller than the originals, so that's a good thing, because when you have a bunch of caps in a group like this one was, and they're all together, there's no air circulation around these caps. But then when you put new ones in, it really opens up the air, the area around it, and allows the air to flow in. You see there's a bunch of caps under there that were replaced. Most of them are film. There's some solid polymers, and those are all in power supply, or you can't see, it's too dark, power supply or emitter bypass positions. Relay was actually one of the best relays I've ever seen in an old stereo of this vintage, and it had very low very low contact resistance. I was about to say ESR, but it's not ESR. I guess you could call it ESR because it is a series resistance, but that's been cleaned and put back. These two caps, they both are test around 9,000 microfarads, so they stay and they're going to continue on their duty. Now I have these lamps here. I don't know if you can see this. It says on it 8 volts AC, and they have those two black things in the center. Those are, I'm assuming those are just diodes to rectify the AC current, and it doesn't seem like there's any capacitor or anything here. And then we have 3 elements, so we're going to replace those. We need to find a suitable power source, so let's have a look at that. Alright, so here's a diagram of the power supply circuit. We have 2 windings. This is your main winding, plus and minus 30 volts, and then here, I can't read that, it's too small. It says 27 volts AC. Okay, so it runs through a fuse. It goes through a fuse and goes down to here, which flows into this 15 ohm resistor. And then it goes to 2 lamps wired in series. These are 14.5 volts, 90 milliamps wired in series, and then it goes up, connects to the other winding. So we're feeding this with AC, 27 volts. Now we need to eliminate this and reinstall LEDs. And for LEDs, I usually find a DC source somewhere in the power supply and tap off of it. It's not a big deal because you're only drawing 5 milliamps, so it's not going to upset any balance of any circuits here. It's just a parasite draw of 5 milliamps, enough to light 2 LEDs. So let's see here. We have this one here is 19.4 volts. We could tap off that one. Oh, you can't even see it. Let's see here. Let's pull this down a bit. There we go. And right here is 19.4 volts. And then we also have this line here is negative 66.5, and then it runs through this transistor and it comes out at negative 42 volts. There's another source that we can consider. I have a feeling, let's see here. This transistor here is a TO-220, and it has very high current capability, more than enough for our LEDs. So I might just go from here, negative 42 volts to ground, and that would be our source. I just need to figure out. Actually, let's measure this first. Let's measure this, and we'll figure out what the real voltage is, because it should be 42 if everything's going good with these 2 Zener diodes. Alright, let's do bias adjustment. So bias adjustment is here on these 2 test points. They're hidden by these emitter resistors. Test point 4 and test point 2, and then on this side we have test point 1 and test point 3. So what we do is connect a voltmeter to this, and we adjust our potentiometers here and here for 10 millivolts plus or minus 2 or 3 millivolts. So let's get connected up and do that first. Alright, so we're ready for our first power up. Let's turn this thing on. Relay click. Power consumption is around 17 watts. Before it was up around 21. Okay, so this is our right channel, or the run on the right anyways. This is around 10 millivolts. That's our bias current. And on the left side we have 3 point something. So I'm going to let this sit for about 10 minutes and stabilize, and then I'll come in and do an adjustment. Alright, while that's warming up, I'm going to do DC balance adjustment. And there is no adjustment for DC balance, but I'm going to check it to make sure it's good. So what we can do is we can get our voltmeter in frame here somehow. And pick one of the off onto ground. Now the spec in the manual says should be less than 100 millivolts. I'm going to find a place here. Less than 100 millivolts. So we can measure. Okay, there's our real voltage. The other collector. Negative rail voltage. Okay, so this here, that's our base, and that's our emitter, and we got 17 millivolts there on that one. Let's try this one. We got 19 millivolts on this channel. So there is no adjustment, but that is well within what it should be. So we're okay that way. So we'll leave that alone. Okay, it's been about 15 minutes now, and on this side we have 10 millivolts, and this side we have 10.2. And I've been slowly tweaking it as it warms up, and this is pretty much room temperature, this heat sink. And our power consumption is 18.6 watts at idle. Okay, so we're done with our adjustments. Let's focus on the lamps. I need to find out a voltage source and what that voltage is so we can do our calculations and get our lamps ready. Alright, here's the LEDs installed. I used two warm white 8mm LEDs. These are big jumbo ones, and they're wired in series, and there is a 6.8K dropping resistor for the whole thing, and I picked off from the negative 41 volt supply. So negative 41 volts through a 6.8K dropping resistor, two LEDs in series, and to ground. And when you turn it on, you get light. And this should be enough light to illuminate the 2 meters. And well, you can't see here now, but when I put it all together. Now, if this isn't enough light, I can always drop the resistor to a lower value to increase the current. Right now I picked a 6.8K because it gives 5 milliamps of current through these two LEDs. Alright, so we're wired in to do a power test. Let's do full power test and see how this goes. Alright, so we have okay, we're live. Let's see here. Speakers B. We should have our tone. It's very quiet. What is going on here? Okay, we have a cock up on our switches. let's do this. Okay, we have left, right, sounds good so far. Main direct. Okay, so let's turn the speakers off. Put it on our dummy load. Let's turn this up. Alright, there's the clipping. Let's turn it down till we get right. Our peak is right there, I think. And we got 22.62 volts RMS. Start the timer, and I'll see you again in 10 minutes. $217 watts. Okay, we're coming up to the 10-minute mark here. I'm just checking the temperatures on the heatsink, and we are up around 55 degrees Celsius. Oh, hang on there, that said 60 something. What? Yeah, 55 degrees. It's getting a little too hot to hold. This side's cooler than this side. But holding up very well. I'm going to turn this down, and then we'll do some square wave tests. You got to be aware this is all exposed mains wiring right here, so you don't want to be putting your hand around this area and getting a zap. That should actually be covered or something, but Yamaha did what they did. So, you got to be careful of that. So I did the 10-minute test alright. Let's do square waves. And let's turn down our sensitivity. Turn up the sensitivity. And let's have a look. We got a very nice square wave there at 1 kilohertz. Quite noisy controls, even though they're cut out. Why is that? That's really odd. The controls are supposed to be cut out. We've got a broken connection here. That's me touching it. Okay. Let's try this first. Bass cut. Bass boost. Maybe I forgot to treat these pots. Maybe that's what's going on. Bass cut. Bass boost. Okay, let's try this one. A little bit of amplitude change there on the bottom of that top trace when I... Okay, let's go 2.5 kilohertz. Treble cut. Treble boost. Quite a big difference here with the other one. Treble cut. Treble boost. High filter. That is the main direct, minus 6 dB. That switch is dirty as well. Okay, this is the loudness control. That's full loudness, and then that's supposed to be flat. Okay, stereo mono. Why we have a drop in? We shouldn't have any attenuation. That's weird. Okay, let's go up in frequency. 2, 2, 3, 4, 5. Looking good. 6, 7, 8, 9, 10. 10 kilohertz right there. It's not bad. It's a fairly fast amplifier. It's doing all right. 11, 12, 13, 14, 15. We lose it right around here somewhere. So 29 kilohertz. And about 70 kilohertz, it turns into a sine wave again. Okay. 10 kilohertz. It's all right. I've seen a lot worse and I've seen better, so. Okay, I think we're done with this. One thing I need to do before I forget is set the meters because they weren't showing correct. So let's turn this up. Let's go back to square sine wave, and let's turn this up until we get 20 volts on the voltmeter. Okay. Okay. $20 volts on the voltmeter. What does our needle say? It's pegged. So we need to adjust. Okay, we are connected to left channel. Left channel, let's adjust left channel. I need to get down so I can see, because I cannot. There we go, right on 50. And then let's do the same for, let's turn this down. Let's do the same for the other channel. Just gonna move my voltmeter over. Adjust this for 20 volts. Okay, right there. And what do we have? Good. We're bang on 50 on both channels. These are Mashashita caps, and I did find some that were leaking. For the most part, they were okay. There was some failed ones here, and some leaking ones. And I did replace 7 transistors. Those are two SA844s with the silver black legs. So I got them out of there, replaced those 7, and then the caps was necessary. Like I said, I found, where is that leaking one? All these Mashashita caps, they're past their due date. They're old. Here it is. This one here. That one you can see is leaking. A bit of corrosion there. but there's a few that tested poor, like 33 microfarad came back at 12 microfarad, something like that. So this needed to be done. Well, there it is, back together and finished. I did have to go in and fix this input selector switch. When I reassembled it, I didn't have it synchronized right. So when it was in auxiliary, it was actually picking up the tuner, and when I turned it to tuner, it was actually picking up the phono. It was just one off, so I had to go take the switch apart, actually remove the switch, take the switch apart, and just move it that one gear tooth just to get it to work. Now it's back to normal. This one was okay. So yeah, it's all done. I'm pleased with the turnout. I was kind of really nervous about this balance potentiometer. It is working now, and you know, you got to be really careful about things like that, because you screw up a balance pot and it renders the whole thing useless. Trying to find a new one, a 4-gang pot with balance control in the middle, it'd be hard, but we worked through it. So this is done, and I'm going to enjoy listening to this one for sure, and we'll see you on the next one. Take care. Thanks for watching.